So I'm going to go over a few problems from this circles review number 2 for your online circles quiz number 2. Remember, you have your quiz on Tuesday. One thing I want to point out here on like problems 1, 3, and 4, and there's a few other in this packet, notice that they have this line that goes through the point. That point is the center, so this is a diameter. So that's helpful to us because here we're trying to find arc XC, but we should know that arc AXC, this whole thing, would be 180. The reason we know that is because that's a diameter, so it's half the circle. This problem is a bit confusing because this 30 degrees is really angle B. It kind of looks like it's angle A. You shouldn't have any on your quiz that you have to kind of figure out. It's just the font is too big to fit up there. So if angle B right here is 30 degrees, and it uses endpoints A and X, that means arc AX is 60 degrees. So if AX is 60, to find XC, you just do 180 minus 60 to get your 120. Okay. Problem number 4. So same kind of idea, LN is a diameter. So that tells us LCN, that whole arc, is 180 degrees. Again, this is a diameter, so it's half the circle. So if LC is 100, then we should know that CN would be the other 80, because these together have to add up to 180. Now if we look here, so again, those are points CN. If we look at angle L, which uses endpoints C and N for the endpoints of the arc, we know that an inscribed angle is half of the arc measure. So this angle here would be 40 degrees because it's, again, half of 80. I know there's a lot of lines going on, but think about it being just like this. This is CLN, and this is 80 degrees, and we cut it in half to get that 40. On 5 through 8, you're doing similar things, except you're trying to find something after you find X. So here on number 8, it's one of the trickier ones. So again, I'm just going to draw this off to the side. This is STA, and this angle here, 7x plus 15, is an inscribed angle. So that tells us this arc here, SA, which has R in the middle, but this whole arc from SRA would have to be 14x plus 30. Where that 14x plus 30 comes from is 2 times 7x plus 15. Again, you doubled the inscribed angle to get the arc measure. So arc SRA is equal to 14x plus 30. But if we look at this picture, arc SRA would be 120 plus 8x minus 12, which simplifies to 8x plus 108. So again, SRA just from here is 120 plus 8x minus 12. If we kind of get rid of these other lines and just look at it like this, we can see SRA, that arc is 14x plus 30. So then you just set these two equal to each other, since they're both the measure of arc SRA. 8x plus 108 equals 14x plus 30. Once you're done, you have to find, so you solve this for x. I think you get x equals 13. And then you end up plugging it in right here. So again, you find x and plug it in because they're trying to find arc AR. All right, next page, starting up at the top. Up here, you're just solving for x. You don't have to plug it back in after you do anything. So on number 10, you have opposite angles in an inscribed quadrilateral. Again, that means every endpoint is on the circle. So opposite angles are supplementary. Remember, supplementary means they add up to 180. So to solve this problem, it's just 22x plus 7 plus 20x plus 5 is equal to 180. On problem number 12, let's see. Okay, so looking here, this is angle Y, here's X, here's C. So I'm just kind of getting rid of these other lines for a minute, and we have a W over here. But this angle 8x plus 2 is an inscribed angle. I wrote it kind of small, sorry. So remember, you double it to get this arc here. So this arc would be 2 times 8x plus 2, or 16x plus 4. So arc XWC here would be 16x plus 4. We don't know how much of it goes to XW and how much goes to WC. We could find out, but we don't really care for this problem. We're just trying to solve for x. So from x to c is 16x plus 4. From c to y is 150. From y to x is 78. We know all the way around the circle has a sum of 360. So we do 16x plus 4 plus 150 plus 78 equals 360. So again, that piece, and then this big piece have a sum of 360. Down here, find the arc or central angle indicated. Assume that lines which appear to be diameters are actually diameters. So here on problem number 14, you have a couple of different diameters. YV is a diameter. UX is a diameter. That helps you because if it's a diameter, you know that the pieces add up to 180. So since this is a diameter right here for UX, we know that 135 plus this piece have to add up to 180. So those together have to be 180. So 180 minus 35 gives us 45 degrees. So this guy right here is 45 degrees. But also, so I'm going to use another color, but again, it's going to get busy. This is a diameter, which tells us that from here to here is 180. So that's 180. So 70 plus 45 is 115. And so 180 minus 45, not minus 45, I'm sorry. 180 minus 115 is 65. So this guy right here is 65. On this problem, we were asked to find the measure of angle UTW. So UTW. So we want this whole angle right here. So we need to find this missing piece. And same thing, if we look at this orange diameter, or we have a couple ways, but if we look at this, we know that this is 180 from Y to V, so this is another 45 degrees. It's the same as this guy. Another way you can tell, remember, the central angle is the same as the arc, and then these are vertical angles. So that's 45, that's 65, and then you would just add the two together. 15 is very similar. You're being asked to find the measure of angle FJE, so you're looking for this guy right here. So we know that guy is 10x plus 6 because it's the same as the arc, but we have to find x first. So same thing, we have a diameter here, which means this is 180 because it's half the circle. So 15x minus 1 plus 10x plus 6 equals 180. Solve for x. Once you get x, remember you want to take it and plug it back in. These problems are asking you to find something, not just x. Problem number 18, so find the segment of the length indicated, assume lines which appear to be tangent are tangent. So what that means, remember tangent lines, oh sorry you can't see it, tangent lines are perpendicular to a circle. So this line appears to be tangent, which means it has a right angle. So I'm going to call this whole guy x, and we do Pythagorean theorem. 12 squared plus x squared equals 20 squared. And you would solve that for x. Again, 20 is the hypotenuse there. But notice this question mark is only half of x. So once you, because it's half of this diameter here, once you get x, you want to divide by 2 to get your answer. All right, 19 and 20, you have to complete the square to find the equation of the circle, and then that'll help you with the center and the radius. Remember, the equation of a circle is x minus h squared plus y minus k squared equals r squared, where hk is the center, and then r is the radius. So on problem number 19, the first thing you want to do is add 1 to both sides and also rearrange the terms is what I would do. So it becomes x squared plus 6x plus y squared equals 1. Alright, so since we have some x's, we have to complete the square for the x's. Half of 6x is 3x. So we get x, 3, 3. This would be 9 that we're missing. So we need to add 9 to both sides. Since we don't have any y's, we just have y squared, that's already a square. That's just y by y. So we don't have anything to do there. So this x's becomes x plus 3 squared plus y squared equals 10. So going back up here, it's x minus h. So since this is plus 3, that tells us our center is negative 3. Y doesn't have anything in parentheses, so it's 0. So negative 3, 0. There's our center. And our radius, it's not 10. Remember, it's r squared, so our radius is the square root of 10. Which, if you use your calculator, is approximately 3.2. So to sketch this circle, you just go up 3.2, down 3.2, right 3.2, and left 3.2. And then you can go ahead and make a circle. '21 and 22 should be a little easier because they're already in graphing form. You just have to find the center and radius. 23 and 24 should be pretty straightforward here. They give you the center and the radius. You just plug them in. Again, I'll write that formula down again. So 25 and 26 get a little bit harder. What you need to do here, so you want to find the equation of the circle. Here they're giving you the ends of a diameter. So I'm going to sketch kind of what this graph would look like. So over here at 9 and up at 8, we have one endpoint. And then over at 5 and up at 10, we have the other endpoint of the diameter. So our circle would end up going, that's not a very good circle, sorry. That's not either. Something like that. Ignore that stuff in the middle. But, so these 2 points, I probably shouldn't have drawn that circle. Those 2 points right there, that's your diameter. Which means, so remember, we need the center and the radius. The center would have to be halfway. There's going to be the center. The center is in the middle of the diameter. So halfway between 5 and 9 would be 7. And halfway between 8 and 10 would be 9. So that tells us here that our center is the point 7, 9. Again, you're finding the midpoint. You could use midpoint formula. I think it's easier just to kind of count what's in the middle of those two. So then this guy right here, half of it would be the radius. So to find the radius, we're going to have to do Pythagorean theorem. So from 9 to 8, the height of that triangle would be 1. From 7 to 9 would be 2. It's a right triangle, so 1 squared plus 2 squared equals r squared. 1 plus 4 is r squared. 5 equals r squared, so r equals the square root of 5. Well, we know the center, we know the radius, so our equation is x minus 7 squared, x minus h, there's h, plus y minus k, k is 9, squared equals the square root of 5 squared. Well, the square root of 5 squared would just be 5. So remember, it's equal to r squared. We already knew right here what r squared was. If you have other questions, let me know either by email or Zoom tomorrow.